Section 3.3 is not really a lot of note-taking. I'm going to ask you to get your graphing calculators out, however. We're going to do some of this in class together. It's a little tough to do without me there to help you with your calculators. But we're going to talk about derivative functions, both numerically and graphically. As I said, get out your graphing calculator and open to page 79 in your text. Now, all they're really doing on pages 78 and 79 is talking about forward and backward difference quotients. What they really are talking about here is things like right and left. So if this is our value of x and we're trying to find from our table of values something really close to x, let's say x is 7 and we're going to use 6.99 or 7.01. The forward difference is simply saying do the slope between 7.01 and 7. The backwards is saying do the slope between 7 and 6.99. And the symmetric would just be the slope from 7.01, f of 6.99, over 7.01 minus 6.99. I think the book uses numbers around 2 instead of around 7, but you get the idea. And you can see from page 79 that when you do it symmetrically, and we talked about this way back when we were just getting values of limits, that it really is closer or a better average if you do the symmetric. Here, instead of just finding values, they're taking slopes. So again, they're looking for derivatives and looking for derivatives close to a specific value. So it would be great if the calculator would help us for this, and it actually can. So get your calculator out, and look under the Math menu and choose number 8, which says N deriv, that stands for numeric derivative, and then it's going to give you some choices. Okay, let's look at the function in the book, which is f of x equals x cubed. Once you get your N deriv, you're going to enter several things. The first is the function, so enter x cubed, then a comma, then an x, comma, and 2. What we've done is we've entered the function value, the variable that we are using, and the value. This is really saying to us that we are looking for the numeric derivative of x cubed for the x value when x equals 2. And then if you push enter, you should get 12. And that is the numeric derivative, or the slope. This is f prime of x, the derivative, and it's found with your calculator. Okay? So this allows us to find f prime of x. Another way of saying f prime of x is y prime. As you'll find, there's lots of different ways to say this, and we want to be well versed in all of the terminology. So f prime of x or y prime, and we can find that numerically with N deriv. Now the other thing that would be nice to do is to be able to find an equation that we could use to find any derivative value at any x or c value. So the derivative function, there exists a function called the derivative function, whose independent variable is x, some x that we choose, and whose dependent is the value of the derivative. So if I have an equation for f of x, I should be able to find an equation for f prime of x in terms of x, so that whatever value I want to find the derivative at, all I have to do is plug it in. Let's take a look at how this looks graphically. Don't want to do anything numerically right now. I want to do this graphically. So let's go back and take a look at how we would do a derivative graphically. Let's take a function and this is in your textbook under example 1, and we're going to use x cubed minus 5x squared minus 8x plus 70. So go into y sub 1 and enter this equation into your graphing calculator. This is a cubic function, and when you look at it, you're going to have to expand your window. If you look on page 80, they go all the way up to 70 here. But my function looks something like this. That's my y sub 1. Now stick with me for a minute. Don't worry about what the book says. What we want now is we want to find a second equation, which will be y prime, or, y prime or f prime of x, that will show the derivative of this. So let's talk about this graph that we have of f of x and its derivatives. Its derivatives are its slopes. So take a look right here when x equals 0. When x equals 0, the derivative should also be 0. And excuse me, I guess it's a little bit to the left here. Let's say it's at, I'm looking back in the textbook, I apologize, it looks more like it's at -1. So f prime of -1 is 0. The slope here is 0. So the derivative graph should pass 0. If you look over here, that looks like about 4 or maybe 4.5. So when x equals 4, again, our derivative at that value is 0. The slope is 0. Therefore, the derivative graph should pass through 0, 0 there. Now, let's look at the slopes to the left of -1. Oh, shoot. I'm sorry. Let me redraw this. So when we go to the left of -1, and that's where we thought the 0 slope was, and at 4 was where we had another 0. Over here to the left, my slopes are all positive numbers, and they're very big positives, and then they gradually come along till they're a little positive and 0. So it's going to be something like this for my derivative. The slopes between -1 and 4 are negative. They start off almost 0. They get steeper and steeper till it's a big negative, and then comes back up to 0. And all the slopes to the right of 4 are positive values. This is my graph of f prime of x. And again, we're now on page 80 in the text. So let's try with our graphing calculator. You have, under y sub 1, you have your original function. Under y sub 2, I want you to go, after you're in y sub 2, I want you to choose the end deriv. This time, instead of typing in the function, we're going to type in y sub 1. That's found under vars. If you don't remember how, take a look when we get to class. You're going to go to the vars menu, choose y vars, I think, is first, and then function, and then choose y sub 1, comma, x, comma, x. This is telling us now we want to find the derivative for this function, the one that we entered in y sub 1, for the x variable for any value of x. You see, we don't have a specific number here. And then push graph. You should have a picture that looks like this. F of x should be like this. F prime should be something like this. They ask you to try this again for example 2 and 3. I know that you don't like reading through these examples on your own, but please do take the time. We'll be doing a lot more of this in class together, but take the time to read through this, and remember, here's the difference. Instead of finding a specific value for a derivative, we are finding this derivative function graphically. That's it.